books, book, camera, Safari, Understanding the IPCC, heading level 1.
Welcome
Link,
to
main,
Understanding the
landmark.
IPCC, 6th presentation.
App switcher. Books, camera, active camera, 0 camera. Photo and video viewer, viewfinder, live timer, camera chooser, 0 people.
Hello.
One face near top edge. Voiceover off.
In exchange for freedom of inquiry, scientists are obliged to explain their work. If science is considered a closed priesthood, too difficult and arcane for the average person to understand, the dangers of abuse are greater. But if science is a topic of general interest and concern, if both its delights and its social consequences are discussed regularly and competently in the schools, the press, and at the dinner table, we have greatly improved our prospects for learning of how the world really is and improving both it and us.
Voiceover on. Camera. Take app switcher. Camera. One face near Safari. Meetup.com and 6 Safari. Open menu. Button. App switcher. Safari. Camera. Close camera. Closing. Books. Safari. Doc. Files. Settings. Safari. Understanding the IPCC. Heading level 1.
Once I stagger around a little bit.
Main. Landmark.
This is the meetup page that we come from. And
Carl Sagan. Heading level 1.
This is
main. Universal messages that could potentially be understood by any extraterrestrial intelligence that might find them. Sagan argued. Voyager Golden Record.
Anyway.
Author. Poet.
There he is, Carl Sagan, author, poet, astrophysicist, astronomer. I was quoting him there from his 1979 Pulitzer Prize winning book, Broke His Brain, in which clearly he's advocating that science should be, should be in a position for every person to access. It should not be hidden away in an ivory tower. And he worked hard to disseminate this information to the rest of us, including me, when I was a little tiny tot, which is what we are trying to do here.
Menu, link, navigation, landmark. Actions available.
So,
special report on the ocean and cryosphere in a changing climate. Heading level 1.
This is the Intergovernmental Panel on Climate Change website, and the special report on the oceans and cryosphere in a changing climate is the report that we are dealing with this time. Pardon me. As I have said often in the past, you can find all of their information on their website. All of these things that I'll be showing you will be linked extensively in the comments pane on YouTube, and I'll of course mention them, and they'll be visible in this video. So, and I strongly repeat again and again and again, all of the information that you'll be encountering, I take directly from their website to establish the credibility of the information, and yet I try to highlight it and choose from amongst it in a manner that will be understandable and hopefully informative, and yet somewhat interesting, I would hope.
Action menu, button. Introduction from Indigenous 6 bullet 5 month action who they are 46 who they are. Number 1, the Intergovernmental Panel on Climate Change and their 2018 synthesis report by a talking game 6 months ago. 1 hour 7 minutes 46 views.
So
heading level
that's
3.
The first video in this series, number 1. We're currently at number 6. If you're just coming upon this for the first time, I strongly urge, again in the comments links, or you can search out a talking game on YouTube, that you go to these videos. The number 1, who they are, and number 2, what they say videos explain a great deal of the foundation of, well, who they are, and what they say. And the third one is why you should care. I think that's what it's called. But anyways, I'm not going to go into the foundations, because otherwise these videos would just be getting longer and longer, and this would be 10 hours by this point, and I'm not kidding. So I strongly recommend, if you're just getting here, that you go to that video. Now, if you're a peer-reviewed academic in climate change, then that won't be necessary, but you probably won't need to watch this video either.
Menu, link, navigation, landmark. Actions available. Monday Mon. App switcher. Safari. Dog. Mail. Safari. Books. Active. Books.
And
Books.
those earlier videos
Page.
will also
4 of
explain
38.
why you're listening to my iPad talk to you, and why I'm wearing sunglasses, and all of that stuff. So this is the beginning of the technical summary for the special report on the oceans and cryosphere in a changing climate. I've managed to get most of the information I need from this one chapter. So
Toolbar. Image. Final draft. Bookmark. Image. Figure TF. References to chapter section. Figure T. Image. Final draft. Bookmarked. Figure. References to TS. This special report assesses new knowledge since the IPCC. All people on Earth depend directly or indirectly on the ocean and cryosphere. The fundamental roles of the ocean and cryosphere in the Earth system include the uptake and redistribution of anthropogenic carbon dioxide and heat by the ocean, as well as their crucial involvement in the hydrological cycle. The cryosphere also amplifies climate changes through snow, ice and permafrost feedbacks. Services provided to people by the ocean and/or cryosphere include food and fresh water, renewable energy, health and well-being, cultural values, trade, and transport. Left brace 1.1. Sustainable development is at risk from emerging and intensifying ocean and cryosphere changes. Ocean and cryosphere changes interact with each of the United Nations Sustainable Development Goals, SDGs. Progress on climate action, SDG 13, would reduce risks to aspects of sustainable development that subject to toolbar. Page 5. Communities living in close connection with polar, mountain, and coastal environments are particularly exposed to the current and future hazards of ocean and cryosphere change. Coasts are home to approximately 28% of the global population, including around 11% living on land less than 10 meters above sea level. Almost 10% of the global population lives in the Arctic or high mountain regions. People in these regions face the greatest exposure to ocean and cryosphere change, and poor and marginalized people here are particularly vulnerable to climate-related hazards and risks. Very high confidence. The adaptive capacity of people, communities and nations is shaped by social, political, cultural, economic, technological, institutional, geographical, and demographic factors. Left brace 1.1. Library. Button. Reading now. Heading. PDF. SPM Summary for Policymakers by T.F.
So,
PDF. Toolbar.
we're going to take a momentary
Page 27 of 28.
reinforcement here. In the Working Group 1 report, which I've covered in an earlier presentation, called The Physical Science Basis of, I don't remember how it goes, but they dealt with something called representative concentration pathways.
Bullet methods that SPM, Summary for Box SPM, 1, Representative Concentration Pathways, RCPs.
They're important because what they are, and this is a review, basically because throughout this report they make many references to RCPs of different levels for different reasons. And so pathways, I'll just remind you, means that there's all kinds of different contributing factors to each pathway. So technology, social impacts, economic development, scientific changes, biological changes. Each pathway is a conglomerate of a bunch of different modeling systems to create a possible pathway. And so without further ado, I'm just going to let them tell you.
Climate change projections in IPCC Working Group I require information about future emissions or concentrations of greenhouse gases, aerosols and other climate drivers. This information is often expressed as a scenario of human activities, which are not assessed in this report. Scenarios used in Working Group I have focused on anthropogenic emissions and do not include changes in natural drivers such as solar or volcanic forcing or natural emissions, for example, of CH4 and N2O. For the fifth assessment report of IPCC, the scientific community has defined a set of 4 new scenarios, denoted representative concentration pathways, RCPs, see glossary. They are identified by their approximate total radiative forcing in year 2100 relative to 1750, 2.6 Wm2 for RCP 2.6, 4.5 Wm2 for RCP 4.5, 6.0 Wm2 for RCP 6.0, and 8.5 Wm2 for RCP 8.5. For the coupled model intercomparison project phase 5, CMIP5 results, these values should be understood as indicative only. As the climate forcing resulting from all drivers varies between models due to specific model characteristics and treatment of short-lived climate forces. These 4 RCPs include 1 mitigation scenario leading to a very low forcing level, RCP 2.6, 2 stabilization scenarios, RCP 4.5 and RCP 6, and 1 scenario with very high greenhouse gas emissions, RCP 8.5. The RCPs can thus represent a range of 21st century climate policies, as compared with the no climate policy of the Special Report on Emissions. Scenarios, SRES, used in the 3rd Assessment Report and the 4th Assessment Report. For RCP 6.0 and RCP 8.5, radiative forcing does not peak by year 2100, for RCP 2.6 it peaks and declines, and for RCP 4.5 it stabilizes by 2100. Each RCP provides spatially resolved datasets of land use change and sector-based emissions of air pollutants, and it specifies annual greenhouse gas concentrations and anthropogenic emissions up to 2100. RCPs are based on a combination of integrated assessment models, simple climate models, atmospheric chemistry and global carbon cycle models. While the RCPs span a wide range of total forcing values, they do not cover the full range of emissions in the literature, particularly for aerosols.
So as it mentions at the end there, a combination of models create the pathway that they're qualifying as RCPs. And there's the 4 numbers, 2.6, 4.5, 6.0, and 8.6, I think it is. Something like that. Notice that, so those numbers, they're not temperatures, they're not even CO2 concentrations. They are the energy contribution to the global system that we have made by the year 2100. So 2.6 watts per meter squared of energy that we've contributed to the Earth system results in the temperature rising, stabilizing, and then declining back to a lower stabilized amount. Whereas with 4.5 and 6.0, 4.5 actually stabilizes by 2100, as it says, and 6.0 and 8.6 continue to rise past 2100, and they've just established 2100 as a time post, as I've mentioned before. So that is watts per meter squared energy in the, and it's not just the atmospheric system, it's the atmospheric and ocean system, because the ocean absorbs actually more energy than the atmosphere does, which we go into later. So, and they mentioned the carbon concentrations, parts per million, coming up next.
Most of the CMIP5 and Earth system model simulations were performed with prescribed CO2 concentrations reaching 421 ppm, RCP 2.6, 538 ppm, RCP 4.5, 670 ppm, RCP 6.0, and 936 ppm, RCP 8.5, by the year 2100, including also the prescribed concentrations of CH4 and N2O. The combined CO2 equivalent concentrations of 475 ppm, RCP 2.6, 630 ppm, RCP 4.5, 800 ppm, RCP 6.0, and 1313 ppm, RCP 8.5. For RCP 8.5, additional CMIP5 Earth system model simulations are performed with prescribed CO2 emissions as provided by the integrated assessment models. For all RCPs, additional calculations were made with updated atmospheric chemistry data and models, including the atmospheric chemistry and climate component of CMIP5, using the RCP prescribed emissions of the chemically reactive gases, CH4, N2O, HFCs, NOx, CO, NMVOC. These simulations enable investigation of uncertainties related to carbon cycle feedbacks and atmospheric chemistry.
Just a point that I pick up is the first four numbers, and they're divided per RPC, clearly, so the bottom one, 420, I believe, is 2.6 watts per meter squared, 420 parts per million. Notice that the first four set of numbers are just for CO2, and the second set of numbers are CO2 equivalent, because methane and nitrous oxide and the other ones, I don't know what they stand for, but they contribute but are outside of CO2 itself. They contribute to for example, methane's got a very high greenhouse warming potential, much higher than CO2. It's much lesser in quantity, but much greater in effect.
29. Toolbar. Page chooser. Page 27. Table of content. Library. Button.
So we're going to go back to the technical summary.
Account. Button. Cover of SPM summary for SPM sum 93. More action. PDF. TS technical summary. PDF. Toolbar.
So that was from
Page
the physical science
5 of
basis.
38.
The summary for policymakers in the physical science basis report, working group 1, and we're back in the special report on climate change, oceans and cryosphere in a changing climate report. That's the one.
Toolbar. Page chooser. Page 5. Page 6. Image. An illustration. Figure TS. 2. Schematic illustration of key components and changes of the ocean and cryosphere, and their linkages in the Earth system through the global exchange of heat, water, and carbon. Section 1.2. Toolbar. Page chooser. Page 6.
Now,
Adjustable.
This time I'm using the in-text images a lot more than I have previously, simply because since I'm able to stay within the technical summary itself, and I don't have to change chapters as I was doing previously, this allows me to actually use the diagrams and charts that go with the text that we're going through. So, however, as I've also mentioned previously, charts and diagrams aren't much good to legally blind presentation people like me. So I will just leave them up for a few seconds while the subtitle is read, so that people who are just listening can pick up on what the chart is about and find it if they want, and have it interpreted or however they want to access it. In any event, I'm going to rely upon you as a viewer to either pause the video and check out the visuals in that state. Look at them for hours if you wish, get a glass of wine and interpret their many varied colors and states. I'm not going to linger on them very much.
Page 7.
But I will be showing them.
Image. Figure TS. 3. Changes in the ocean and cryosphere that have already occurred, and projected future changes this century under low, RCP 2.6, and high, RCP 8.5, greenhouse gas emission scenarios. Toolbar. Page 8. Table start near term end of scenario mean globe RC 0 1 dot RC 1 dot 1 dot RC 1 dot 2 RC 1 dot 3 dot global RCP 0 dot 0 dot RCP 0 dot 90. Characteristics of ocean and cryosphere change include thresholds of abrupt change, long-term changes that cannot be avoided, and irreversibility, high confidence. Ocean warming, acidification and deoxygenation, ice sheet and glacier mass loss, and permafrost degradation are expected to be irreversible on timescales relevant to human societies and ecosystems. Long response times of decades to millennia mean that the ocean and cryosphere are committed to long-term change even after atmospheric greenhouse gas concentrations and radiative forcing stabilize. High confidence. Ice melt or the thawing of permafrost. 4. Calculated following the same toolbar. Page 9. Societies will involve thresholds, state changes that allow for abrupt, nonlinear responses to ongoing climate warming. High confidence. These characteristics of ocean and cryosphere change pose risks and challenges to adaptation. Left brace 1.1. Societies will be exposed, and challenged to adapt, to changes in the ocean and cryosphere even if current and future efforts to reduce greenhouse gas emissions keep global warming well below 2 degrees Celsius. Very high confidence. Ocean and cryosphere-related mitigation and adaptation measures include options that address the causes of climate change, support biological and ecological adaptation, or enhance societal adaptation. Most ocean-based local mitigation and adaptation measures have limited effectiveness to mitigate climate change and reduce its consequences at the global scale, but are useful to implement because they address local risks, often have benefits such as biodiversity conservation, and have few adverse side effects. Effective mitigation at a global scale will reduce the need and cost of adaptation, and reduce the risks of surpassing limits to adaptation. Ocean-based carbon dioxide removal at the global scale has potentially large negative ecosystem consequences. Left brace cross-chat. The scale and cross-boundary dimensions of changes in the ocean and cryosphere challenge the ability of communities, cultures and nations to respond effectively within existing governance frameworks. High confidence. Profound economic and institutional transformations are needed if climate-resilient development is to be achieved. High confidence. Changes in the ocean and cryosphere, the ecosystem services that they provide, the drivers of those changes, and the risks to marine, coastal, polar and mountain ecosystems occur on spatial and temporal scales that may not align within existing governance structures and practices. Medium confidence. This report highlights the requirements for transformative governance, international and transboundary cooperation, and greater empowerment of local communities in the governance of the ocean, coasts, and cryosphere in a changing climate. Left brace 1.5, 1, toolbar. Page chooser. Page 9. Page 10. Image. Figure TS. 4. There are options for risk reduction through adaptation. Adaptation can reduce risk by addressing one or more of the 3 risk factors: vulnerability, exposure, and / or hazard. The reduction of vulnerability TS to high mountain areas. The cryosphere. Observation of the cryosphere, including snow, glaciers, permafrost, lake and river ice, is an integral element of high mountain regions, which are home to roughly 10% of the global population. Widespread cryosphere changes affect physical, biological and human systems in the mountains and surrounding lowlands, with impacts evident even in the ocean. Building on the IPCC's 5th Assessment Report, AR5, this chapter assesses new evidence on observed recent and projected changes in the mountain cryosphere as well as associated impacts, risks and adaptation measures related to natural and human systems. Impacts in response to climate changes independently of changes in the cryosphere are not assessed in this chapter. Polar mountains are included in Chapter 3, except those in Alaska and adjacent Yukon, Iceland, and Scandinavia, which are included in this chapter. Observations of cryospheric changes, impacts, and adaptation in high mountain areas. Observations show general decline in low elevation snow cover, high confidence, glaciers very high confidence, and permafrost, high confidence, due to climate change in recent decades. Snow cover duration has declined in nearly all regions, especially at lower elevations, on average by 5 days per decade, with a likely range from 0 to 10 days per decade. Low elevation snow depth and extent have declined, although year-to-year variation is high. Mass change of glaciers in all mountain regions, excluding the Canadian and Russian Arctic, Svalbard, Greenland and Antarctica was very likely -490 plus or minus 100 kilograms m2 years 1, 123 plus or minus 24 gt year 1, in 2006 to 2015. Regionally averaged mass budgets were likely most negative, less than -850 kgm 2 years 1, in the southern Andes, Caucasus and Central Europe, and least negative in high mountain Asia, 150 plus or minus 110 kilograms m 2 years 1, but variations within regions are strong. Between 3.6 and 5.2 million km2 are underlain by permafrost in the 11 high mountain regions covered in this chapter, corresponding to 27-29% of the global permafrost area. Medium confidence. Sparse and unevenly distributed measurements show an increase in permafrost temperature high confidence, for example, by 0.19 plus or minus 0.05 op on average for about 28 locations in the European Alps, Scandinavia, Canada, and Asia during the past decade. Other observations reveal decreasing permafrost thickness and loss of ice in the ground. Left brace 2, 2, 2, 2, 2, 3, 2, 2, 4, figure TS, 5 right brace.
Just a reminder, since they start to bring up GTs, which is not a fast car, but in fact gigaton. I don't remember if it was number 3 or number 4, where I actually went into a minor description of what gigatons are, and they're just mind-bending is what they are. A gigaton, if I remember correctly, as an example of our attempt to imagine what a gigaton is. So the entire population of the planet, what is it, like 6.5, 7 million people, 7 billion people? I don't remember what it is. But so the estimate was, I believe, not twice the mass of the population of the planet. I think it was 1.7, I think was what they came up with. So the entire living population of humans on Earth, more than once, so 1.5 times, that mass is a gigaton. 1 gigaton. So not your whole country or continent, but the entire planet worth of people, if we stood on a scale. A gigaton is a hell of a big thing. So when they mention gigatons, just keep that in mind.
Subject to Copied TS10 Total Toolbar. Page 11. Changes in snow and glaciers. Glacier. Final draft. Glacier. Snow and permafrost decline has altered the frequency, magnitude and location of most related natural hazards. High confidence. Exposure of people and infrastructure to natural hazards has increased due to growing population, tourism and development. High confidence. Glacier retreat and permafrost thaw have decreased the stability of mountain slopes and the integrity of infrastructure. High confidence. The number and area of glacier lakes has increased in most regions in recent decades. High confidence. But there is only limited evidence that the frequency of glacier lake outburst floods has changed. In some regions, snow avalanches involving wet snow have increased. Medium confidence. And rain on snow floods have decreased at low elevations in spring and increased at high elevations in winter. Medium confidence. The number and extent of wildfires have increased in the western USA partly due to early snow melt. Medium confidence. Left brace 2. Changes in snow and glaciers have changed the amount and seasonality of runoff in snow-dominated and glacier-fed river basins. Very high confidence, with impacts on agriculture. Medium confidence. Winter runoff has increased in recent decades due to more precipitation falling as rain. High confidence. In some glacier-fed rivers, summer and annual runoff have increased due to intensified glacier melt, but decreased where glacier melt water has lessened as glacier area shrinks. Decreases were observed especially in regions dominated by small glaciers, such as the European Alps. Medium confidence. In some areas, where glacier and snow meltwater has decreased, especially where other climatic drivers or socio-economic stresses are also present, agricultural productivity has declined, e.g., in the western USA, high mountain Asia and the tropical Andes. Medium confidence. There is limited evidence of impacts on operation and productivity of hydropower facilities resulting from changes in seasonality and both increases and decreases in water input. For example, in Central Europe, Iceland, Western Canada and USA, and low-latitude Andes. Left brace 2, 3. Species composition and abundance have markedly changed in high mountain ecosystems in recent decades, very high confidence, partly due to changes in the cryosphere, high confidence. Reductions in glacier and snow cover have directly altered the structure of many freshwater communities, high confidence. Reduced snow cover has negatively impacted the reproductive fitness of some snow-dependent plant and animal species, including foraging and predator-prey relationships of mammals, high confidence. Upslope migration of individual species, mostly due to warming and to a lesser extent due to cryosphere-related changes, has often increased local species richness, very high confidence. Some cold-adapted species, including endemics, in terrestrial and freshwater communities have declined in abundance, high confidence. While the plant productivity has generally increased, the actual impact on provisioning, regulating, and cultural ecosystem services varies greatly, high confidence, left brace 2, 3, 3 right brace.
I suppose I ought to have mentioned it before, but anyway, just a reminder, if you're wondering where the oceans are in all this mountaintop talk, a cryosphere is anything frozen, so ice, glaciers, snow, frozen tundra, where if the water is frozen, then it's a cryosphere, and so that's why, given the high mountain areas and the polar regions parts, it's not all ocean related, it's all water related, in fact.
Toolbar. Page 12. Likely final draft book. Likely most river runoff. Current trends in cryosphere related changes in high mountain ecosystems are expected to continue and impacts to intensify, very high confidence. While high mountains will provide new and greater habitat area, including refugia for lowland species, both range expansion and shrinkage are projected, and at high elevations this will lead to population declines, high confidence. The latter increases the risk of local extinctions, in particular for freshwater cold-adapted species, medium confidence. Without genetic plasticity and or behavioral shifts, cryospheric changes will continue to negatively impact endemic and native species, such as some coldwater fish, e.g., trout, and species whose traits directly depend on snow, e.g., snowshoe hares, or many large mammals, medium confidence. The survival of such species will depend on appropriate conservation and adaptation measures, medium confidence. Many projected ecological changes will alter ecosystem services, high confidence, affecting disturbance regimes, e.g., fire, rockfall, slope erosion, with considerable impacts on people, medium confidence, left brace 2, toolbar. Page 13. Page 14. Image. Figure TS. 5. Synthesis of regional consequences and impacts in ocean, polar and high mountain regions assessed in SROCCC. For each region, physical changes red boxes, impacts on key ecosystems green boxes, and impacts on human systems and ecosystem services, blue boxes, are shown. Physical changes are attributable to rising greenhouse gas concentrations and associated warming at either global or regional scales with the indicated confidence. Toolbar. Page 15. Arctic final draft TS. This chap TS. 3 polar regions.
I don't believe I mentioned it. Just as a reminder, I will be definitely having the title for every chapter read, and the same reason that I'm having the information from the charts read, so that anyone just listening to this will know where we are, because I can assure you, as a person with accessibility needs, that keeping track of where one is in this program is important. So this is where we are. Find
TS. 3 polar regions. This chapter assesses the polar regions are losing ice, and their oceans are changing rapidly. The consequences of this polar transition extend to the whole planet, and are affecting people in multiple ways. Arctic surface air temperature has likely increased by more than double the global average over the last 2 decades, with feedbacks from loss of sea ice and snow cover contributing to the amplified warming. For each of the 5 years since AER 5, 2014, 2018, Arctic annual surface air temperature exceeded that of any year since 1900. During the winters, January-March, of 2016 and 2018, surface temperatures in the central Arctic were 6 degrees Celsius above the 1981-2010 average, contributing to unprecedented regional sea ice absence. These trends and extremes provide medium evidence with high agreement of the contemporary coupled atmosphere-cryosphere system moving well outside the 20th century envelope. Left brace box 3.1. The Arctic and Southern Oceans are continuing to remove carbon dioxide from the atmosphere and to acidify. High confidence. There is medium confidence that the amount of CO2 drawn into the Southern Ocean from the atmosphere has experienced significant decadal variations since the 1980s. Rates of calcification, by which marine organisms form hard skeletons and shells, declined in the Southern Ocean by 3.9 plus or minus 1.3% between 1998 and 2014. In the Arctic Ocean, the area corrosive to organisms that form shells and skeletons using the mineral aragonite expanded between the 1990s and 2010, with instances of extreme aragonite undersaturation. Left brace 3. Both polar oceans have continued to warm in recent years, with the Southern Ocean being disproportionately and increasingly important in global ocean heat increase. High confidence. Over large sectors of the seasonally ice-free Arctic, summer upper mixed layer temperatures increased at around 0.50 degrees Celsius per decade during 1982-2017. Primarily associated with increased absorbed solar radiation accompanying sea ice loss, and the inflow of ocean heat from lower latitude increased since the 2000s. High confidence. During 1970-2017, the Southern Ocean south of 30 degrees south accounted for 43% of the global ocean heat gain in the upper 2,000 meters. High confidence. Despite occupying 25% of the global ocean area. In recent years, 2005-2017, the Southern Ocean was responsible for an increased proportion of the global ocean heat increase, 62%. High confidence. Left brace 3. Toolbar. Page chooser. Page 15. Page 16. It is very, bookmark, fine, shipping, permafrost, climate, limited, it is subject, it is, climate, permafrost temperatures have increased to record, it is, final draft, bookmark, it is very likely that Arctic sea ice extent continues to decline in all, it is very likely that Antarctic, toolbar, page chooser, page 16, adjustable.
Excuse me, sorry.
Shipping Act, it is very light, final draft it is, Shipping Act, permafrost, climate-related changes to Arctic hydrology, wildfire and abrupt thaw are occurring, high confidence, with impacts on vegetation and water and food security. Snow and lake ice cover has declined, with June snow extent decreasing 13.4 plus or minus 5.4% per decade, 1967-2018. High confidence. Runoff into the Arctic Ocean increased for Eurasian and North American rivers by 3.3 plus or minus 1.6% and 2.0 plus or minus 1.8% respectively. 1976-2018. Medium confidence. Area burned and frequency of fires, including extreme fires, are unprecedented over the last 10,000 years. High confidence. There has been an overall greening of the tundra biome, but also browning in some regions of tundra and boreal forest, and also changes in the abundance and distribution of animals including reindeer and salmon. High confidence. Together, these impact access to, and food availability within, herding, hunting, fishing, forage and gathering areas, affecting the livelihood, health and cultural identity of residents including indigenous peoples. High confidence. Left brace 3. Limited knowledge, financial resources, human capital and organizational capacity are constraining adaptation in many human sectors in the Arctic. High confidence. Harvesters of renewable resources are adjusting timing of activities to changes in seasonality and less safe ice travel conditions. Municipalities and industry are addressing infrastructure failures associated with flooding and thawing permafrost, and coastal communities and cooperating agencies are in some cases planning for relocation. High confidence. In spite of these adaptations, many groups are making decisions without adequate knowledge to forecast near and long-term conditions, and without the funding, skills and institutional support to engage fully in planning processes. High confidence. Left brace 3. It is extremely likely that the rapid ice loss from the Greenland and Antarctic ice sheets during the early 21st century has increased into the near present day, adding to the ice sheet contribution to. Subject to copied at TS. Toolbar. Page 17. Global sea level final draft. Global sea level rise. From Greenland, the 2012-2016 ice losses, minus 247 plus or minus 15 GT/1, was similar to those from 2002-2011, minus 263 plus or minus 21 GT/1, and extremely likely greater than from 1992-2001, minus 8 plus or minus 82 GT/1. Summer melting of the Greenland ice sheet has increased since the 1990s, very high confidence, to a level unprecedented over at least the last 350 years, and 2 to 5-fold the pre-industrial level, medium confidence. From Antarctica, the 2012-2016 losses, minus 199 plus or minus 26 GT/1, were extremely likely greater than those from 2002-2011, minus 82 plus or minus 27 GT/1, and likely greater than from 1992-2001, minus 51 plus or minus 73 GT/1. Antarctic ice loss is dominated by acceleration, retreat and rapid thinning of major West Antarctic ice sheet outlet glaciers. Very high confidence, driven by melting of ice shelves by warm ocean waters. High confidence. The combined sea level rise contribution from both ice sheets for 2012-2016 was 1.2 plus or minus 0.1 millimeters (1), a 29% increase on the 2002-2011 contribution and a 700% increase on the 1992-2001 period. Left brace 3. Mass loss from Arctic. There is limited evidence and high agreement that recent Antarctic ice sheet mass losses could be irreversible over decades to millennia. Rapid mass loss due to glacier flow acceleration in the Amundsen Sea embayment of West Antarctica and in Wilkes Land, East Antarctica, may indicate the beginning of marine ice sheet instability. But observational data are not yet sufficient to determine whether these changes mark the beginning of irreversible retreat. Left brace 3. The polar regions will be profoundly different in future compared with today, and the degree and nature of that difference will depend strongly on the rate and magnitude of global climatic change. 6. This will challenge adaptation responses regionally and worldwide. It is very likely both polar oceans will be increasingly affected by CO2 uptake, causing conditions corrosive for calcium carbonate shell-producing organisms. High confidence, with associated impacts on marine organisms and ecosystems. Medium confidence. It is very likely that both the Southern Ocean and the Arctic Ocean will experience year-round conditions of surface water undersaturation for mineral forms of calcium carbonate by 2100 under RCP 8.5. Under RCP 2.6 the extent of undersaturated waters are reduced markedly. Imperfect representation of local processes and sea ice interaction in global climate models limit the ability to project the response of specific polar areas and the precise timing of undersaturation at seasonal scales. Differences in sensitivity and the scope for adaptation to projected levels of ocean acidification exist across a broad range of marine species groups. Left brace 3, 2, 1, 3, 2, 2, 3. 3, 2, 3 right brace.
So just so you don't have to go back and look, a friendly reminder, about RCP 2.6 versus 8.5, and they compare the extremes throughout the rest of this report. 2.6 watts per meter squared, the temperature has risen by 2100, stabilized, and then declined again to whatever the 2.6 watts per meter squared temperature stabilizes at by 2100, as opposed to 8.5, I think it is, which is still rising at 2100 and is the highest component with the highest concentration of CO2 at that point or now.
Future climate-induced changes in the polar ocean. Toolbar. Choose page 18. The projected effects of unique biodiversity. Final draft technical summary IPCC SR Ocean. Unique the projected effect. Widespread disappearance of Arctic near surface permafrost is projected to occur this century as a result of warming, high confidence, with important consequences for global climate. By 2100, near-surface permafrost area will decrease by 66% for RCP 2.6 and 30-99% for RCP 8.5. This could release tens to 100s of GTC as carbon dioxide and methane to the atmosphere for RCP 8.5, with the potential to accelerate climate change. Medium confidence. Methane will contribute a small proportion of these additional carbon emissions, on the order of 0.010.06 GTCH for years 1, but could contribute 70% of the total permafrost, affected radiative forcing because of its higher warming potential. There is medium evidence but with low agreement whether the level and timing of increased plant growth and replenishment of soil will compensate these permafrost carbon losses. Left brace 3, 4, toolbar, page 19. Institutional strategic final book the capacity of governance systems in polar regions to respond to climate change has strengthened recently, but the development of these systems is not sufficiently rapid or robust to address the challenges and risks to societies posed by projected changes. High confidence. Human responses to climate change in the polar regions occur in a fragmented governance landscape. Climate change, new polar interests from outside the regions, and an increasingly active role played by informal organizations are compelling stronger coordination and integration between different levels and sectors of governance. The governance landscape is currently not sufficiently equipped to address cascading risks and uncertainty in an integrated and precautionary way within existing legal and policy frameworks. High confidence. Left brace 3, 5, TS, 4. Capital S, E, A, capital L, E, V, E, L, capital R, I, S, E, A, N, D, capital I, M, P, L, I, C, A, T, I, O, N, S, F, O, R, coasts and communities.
So, it's the IPCC spelling bee, courtesy of Esmeralda. So, sea level rise and implications for coasts and what was it? Low level communities? I can't remember. You can see it, hopefully. Yes.
This chapter is global mean sea level, GMSL, is rising, virtually certain, and accelerating, high confidence. The sum of glacier and ice sheet contributions is now the dominant source of GMSL rise, very high confidence. GMSL from tide gauges and altimetry observations increased from 1.4 mm year 1 over the period 1901 to 1990 to 2.1 mm year 1 over the period 19702015 to 3.2 mm year 1 over the period 1993 to 2015 to 3.6 mm year 1 over the period 2005 to 2015. High confidence. The dominant cause of global mean sea level rise since 1970 is anthropogenic forcing. High confidence. 4.2.2 toolbar, page 20. Coastal ecosystems are already impacted by the combination of sea level rise, other climate-related ocean changes, and adverse effects from human activities on ocean and land. High confidence. Attributing such impacts to sea level rise, however, remains challenging due to the influence of other climate-related and non-climatic drivers such as infrastructure development and human-induced habitat degradation. High confidence. Coastal ecosystems, including salt marshes, mangroves, vegetated dunes and sandy beaches, can build vertically and expand laterally in response to SLR, though this capacity varies across sites. High confidence. These ecosystems provide important services that include coastal protection and habitat for diverse biota. However, as a consequence of human actions that fragment wetland habitats and restrict landward migration, coastal ecosystems progressively lose their ability to adapt to climate-induced changes and provide ecosystem services, including acting as protective barriers. High confidence. 4.3.2.3.
Let's hear it for protective barriers, especially natural ones.
Toolbar. Page 21. Chapter Box 5. Accompany the cross statements. 7. Chapter accompany unknown path of may or subject to appear may unknown path anthropogenic subside contribution sea level does not and millennia indic 4. There is low confidence underlying physics century is final draft technical summary century is characterized underlying physical there is low confidence in threshold temperatures for ice sheet instabilities and the rates of GMSL rise they can produce. 4.2 millennia indicate multi-meter rise in sea level for RCP 8.5, medium confidence. Sea level does not and will not rise uniformly. Contributions will generate, in the absence of adaptation, more in the expected impacts of sea level rise on coastal ecosystems over the course of the century include habitat contraction, loss of functionality and biodiversity, and lateral and inland migration. Impacts will be exacerbated in cases of land reclamation and where anthropogenic barriers prevent inland migration of marshes and mangroves and limit the availability and relocation of sediment. High confidence. Under favorable conditions, marshes and mangroves have been found to keep pace with fast rates of SLR, e.g., greater than 10 mm/year. But this capacity varies significantly depending on factors such as wave exposure of the location, tidal range, sediment trapping, overall sediment availability, and coastal squeeze. High confidence. 4.3 In the absence of adaptation, more intense and frequent extreme sea level events, together with trends in coastal development, will increase expected annual flood damages by 2-3 orders of magnitude by 2100. High confidence. However, well-designed coastal protection is very effective in reducing expected damages and cost-efficient for urban and densely populated regions, but generally unaffordable for rural and poorer areas. High confidence. Effective protection requires investments on the order of tens to several hundreds of billions of US dollars per year globally. High confidence. While investments are generally cost-efficient for densely populated and urban areas, high confidence. Rural and poorer areas will be challenged to afford such investments with relative annual costs for some small island states amounting to several % of GDP. High confidence. Even with well-designed hard protection, the risk of possibly disastrous consequences in the event of failure of defenses remains. 4.3.4 Toolbar. Page 22. Risk relate final draft book risk relate choosing and implementing responses. All types of technical choosing and implementing responses to sea level rise presents society with profound governance challenges and difficult social choices, which are inherently political and value-laden. High confidence. The large uncertainties about post-2050 SLR, and the substantial impact expected, challenge established planning and decision-making practices and introduce the need for coordination within and between governance levels and policy domains. SLR responses also raise equity concerns about marginalizing those most vulnerable and could potentially spark or compound social conflict. High confidence. Choosing and implementing responses is further challenged through a lack of resources, vexing trade-offs between safety, conservation and economic development, multiple ways of framing the SLR problem, power relations, and various coastal stakeholders having conflicting interests in the future development of heavily used coastal zones. High confidence. 4.4.2 Toolbar. Page 23. Page 24. Image. A group figure TS 6. The effect of mean average sea level rise on extreme sea level events at coastal locations. Extreme sea level events refer to coastal water levels which occurred on average once per century during recent past. 1986, toolbar. Page 25. Page 26, Figure TS. 5 changing, final draft Figure TS. 5 changing ocean, marine ecosystems, and dependent communities. The ocean is essential for all observations, climate-related trends, impact. The TS. Figure TS. 7. Risk related to sea level rise for low-lying coastal areas, benefits of adaptation, response options and adaptive decision-making to address them. Paneler describes global mean sea level rise, GMSL, scenarios and related risk to archetypal local geographies. This assessment focuses on the additional risks due to sea level rise, TS. 5 changing ocean, marine ecosystems, and dependent communities. The ocean is essential for observation, carbon emission. The ocean has warmed unabated since 2005, continuing the clear multi-decadal ocean warming trends documented in the IPCC Fifth Assessment Report, AR5. The warming trend is further confirmed by the improved ocean temperature measurements over the last decade. The 0-700 meters and 700-2000 m layers of the ocean have warmed at rates of 5.31 plus or minus 0.48 and 4.02 plus or minus 0.97 Zhai from 2005 to 2017. The long-term trend for 0-700 meters and 7.00-2000 M layers have warmed 4.35 plus or minus 0.8 and 2.25 plus or minus 0.64 Zhai from 1970 to 2017 and is attributed to anthropogenic influences. It is likely the ocean warming has continued in the abyssal and deep ocean below 2,000 meters, southern hemisphere and southern ocean. Left brace 1, 8, toolbar. Page chooser, page 27. Multiple datasets and models show that the rate of ocean uptake of atmospheric CO2 has continued to strengthen in the recent 2 decades in response to the increasing concentration of CO2 in the atmosphere. The ocean is continuing to acidify in response to ongoing ocean carbon uptake. The open ocean surface water pH is observed to be declining, virtually certain, by a very likely range of 0.017 to 0.027 pH units per decade since the late 1980s across individual time series observations longer than 15 years. There is a growing consensus that the open ocean is losing oxygen overall with a very likely loss of 0.5 to 3.3% between 1970 2010 from the ocean surface to 1,000 meters, medium confidence. In response to ocean warming and increased stratification, open ocean nutrient cycles are being perturbed and there is high confidence that this is having a regionally variable impact on primary producers. Ocean warming has contributed to observed changes in biogeography of organisms ranging from phytoplankton to marine mammals, high confidence, consequently changing community composition, high confidence, and in some cases, altering interactions between organisms, medium confidence. Warming-induced range expansion of tropical species to higher latitudes has led to increased grazing on some coral reefs, rocky reefs, seagrass meadows and epipelagic ecosystems, leading to altered ecosystem structure. Medium confidence. Fisheries catches and their composition in many regions are already impacted by the effects of warming and changing primary production on growth, reproduction and survival of fish stocks. High confidence. Warming-induced changes in spatial distribution and abundance of fish stocks have already challenged the management of some important fisheries and their economic benefits. High toolbar. Page 28. TS Technique Markup. Appearance. Search. Bookmarked. Final draft. Confidence.
High confidence.
For existing coastal ecosystems are observed to be under stress from ocean warming and sea level rise that are exacerbated by non-climatic pressures from human activities on ocean and land. High confidence. Global wet, coastal and nearshore ecosystems including salt marshes, mangroves, and vegetated dunes in sandy beaches have a varying capacity to build vertically and expand laterally in response to sea level rise. 3 out of the 4 major eastern boundary upwelling ecosystems have shown large-scale wind intensification in the past 60 years, high confidence. Since the early 1980s, the occurrence of harmful algal blooms, HABs, and pathogenic organisms, e.g., Vibrio, has increased in coastal areas in response to warming, deoxygenation and eutrophication, with negative impacts on food provisioning. Many frameworks for climate-resilient coastal adaptation have been developed since AER5, with substantial variations in approach between and within countries, and across development status, high confidence, projections, scenarios and time horizons. Climate models project significant changes in the ocean state over the coming century. Under the high emissions scenario, RCP 8.5, the impacts by 2090 are substantially larger and more widespread than for the low emissions scenario, RCP 2.6, throughout the surface and deep ocean, including warming, virtually certain, ocean acidification, virtually certain, decreased stability of mineral forms of calcite. Subject to copied at TS toolbar. Page 29. TS technique markup appearance search bookmarked. Final draft virtually certain oxygen loss very likely reduced near surface nutrients likely as not decreased net primary productivity high confidence reduced fish production likely and loss of key ecosystem services medium confidence that are important for human well-being and sustainable development. Left brace 5. By 2100 the ocean is very likely to warm by 2 to 4 times as much for low emissions, RCP 2.6, and 5 to 7 times as much for the high emissions scenario, RCP 8.5, compared with the observed changes since 1970. The upper ocean will continue to stratify. By the end of the century the annual mean stratification of the top 200 meters, averaged between 60 degrees south and 60 degrees north relative to the 1986 to 2005 period, it is very likely that the majority of coastal regions will experience statistically significant changes in tidal amplitudes over the course of the 21st century. It is virtually certain that surface ocean pH will decline by 0.036, 0.042 or 0.287, 0.29 pH units by 2081 to 2100, relative to 2006, 2015. For the RCP 2.6 or RCP 8.5 scenarios, respectively, oxygen is projected to decline further. Globally, the oxygen content of the ocean is very likely to decline by 3.23.7% by 2081-2100 relative to 2006-2015. Overall, nitrate concentrations in the upper 100 meters are very likely to decline by 9.14% across CMIP5 models by 2081-2100 relative to 2006-2015. Climate models project that net primary productivity will very likely decline by 4.11% for RCP 8.5 by 2081-2100 relative to 2006-2015. Subject to copy toolbar. Page 30, page 30, page 32, page 33, page 34. Image. Figure TS. 8. Projected changes and risks for selected ocean regions under low, left, representative concentration pathway RCP 2.6, and high, right, RCP 8.5, greenhouse gas emission scenarios. Projected average. Toolbar. Page 35. Ongoing and final draft, TS, 6 extremes, abrupt changes and managing risks. This chapter, ongoing and anthropogenic climate change has increased precipitation, winds and extreme sea level events associated with a number of observed tropical and extratropical cyclones, high confidence. For example, studies have shown that the rainfall intensity of tropical cyclone Harvey increased by at least 8% due to climate change. Left brace 6.3, anthropogenic, extreme wave, marine heatwaves, periods of extremely high ocean temperatures, have negatively impacted marine organisms and ecosystems in all ocean basins over the last 2 decades, including critical foundation species such as corals, seagrasses and kelps. Very high confidence. Satellite observations reveal that marine heatwaves have very likely doubled in frequency between 1982 and 2016, and that they have also become longer lasting, more intense and extensive. Between 2006 and 2015, 84% to 90%, very likely range, of all globally occurring marine heatwaves are attributable to the temperature increase since 1850-1900. Left brace 6 point. Both paleoclimate and modern observations suggest that the strongest El Niño and La Niña events since the pre-industrial have occurred during the last 50 years. Medium confidence. There have been 3 occurrences of extreme El Niño events during the modern observational period, 1982 to 1983, 1997 to 1998, 2015 to 2016, all characterized by pronounced rainfall in the normally dry equatorial East Pacific. There have been 2 occurrences of extreme La Niña, 1988 to 1989, 1998 to 1999. El Niño and La Niña variability during the last 50 years is unusually high compared with average variability during the last millennium. Left brace 6.5, figure 6.5 right brace. Toolbar. Page 36. Climate change is modifying multiple types of climate-related events or hazards in terms of occurrence, intensity and periodicity. It increases the likelihood of compound hazards that comprise simultaneously or sequentially occurring events to cause extreme impacts in natural and human systems. Compound events in turn trigger cascading impacts. High confidence. 3 case studies are presented in the chapter. I. Tasmania's summer of 2015/16. 2. The Coral Triangle N. 2. Hurricanes of 2017. Left brace 6.8. Box 6.1 right brace. Projections of ocean and cryosphere change and hazards to ecosystems and human society under low and high emission futures. An increase in the average intensity of tropical cyclones, and the associated average precipitation rates is projected for a 2 degrees Celsius global temperature rise. Medium confidence. Wave heights are projected to increase across the Southern Ocean, tropical Eastern Pacific and Baltic Sea and decrease over the North Atlantic and Mediterranean Sea under RCP 4.5 and RCP 8.5. High confidence. Marine heatwaves will further increase in frequency, duration, spatial extent and intensity under future global warming. Very high confidence, pushing some marine organisms, fisheries and ecosystems beyond the limits of their resilience. Extreme El Niño and La Niña events are likely to occur more frequently with global warming and are likely to intensify existing impacts, with drier or wetter responses in several regions across the globe. Lack of long-term sustained Indian and Pacific Ocean observations, and inadequacies in the ability of climate models to simulate the magnitude of trade wind decadal variability and the inter-ocean link. The AMOC will very likely weaken over the 21st century. High confidence, although a collapse is very unlikely. Medium confidence, subject to periodic. Toolbar. Page 37. Strengthening impacts from further changes in tropical and extratropical cyclones, marine heatwaves, extreme El Niño and La Niña events and other extremes will exceed the limits of resilience and adaptation of ecosystems and people, leading to unavoidable loss and damage. Medium confidence. Left brace, strengthening the global responses in the context of sustainable development goals and charting climate-resilient development pathways for oceans and cryosphere. There is medium confidence that including extremes and abrupt changes, such as AMOC weakening, ice sheet collapse, WACE and GIS, leads to a several-fold increase in the cost of carbon emissions. Medium confidence. If carbon emissions decline, the risk of extremes and abrupt changes are reduced, creating co-benefits. Left brace 6. For tropical and extratropical cyclones, investment in disaster risk reduction, flood management, ecosystem and engineered, and early warning systems decreases economic loss. Medium confidence. But such investments may be hindered by limited local capacities, such as increased losses and mortality from extreme winds and storm surges in less developed countries despite adaptation efforts. There is emerging evidence of increasing risks for locations impacted by unprecedented storm trajectories, low confidence. Managing the risk from such changing storm trajectories and intensity proves challenging because of the difficulties of early warning and its receptivity by the affected population. High confidence. Left brace. Limiting global warming would reduce the risk of impacts of marine heatwaves, but critical thresholds for some ecosystems e.g., kelp forests, coral reefs, will be reached at relatively low levels of future global warming. High confidence. Full stop. Early warning systems, producing skillful forecasts of marine heatwaves, can further help to reduce the vulnerability in the areas of fisheries, tourism and conservation, but are yet unproven at large scale. Medium confidence. DART. Left brace 6. Sustained long-term monitoring and improved forecasts can be used in managing the risks of extreme El Niño and La Niña events associated with human health, agriculture, fisheries, coral reefs, aquaculture, wildfire, drought and flood management. High confidence. Left brace 6.5. Right brace. Extreme change in the trade wind system and its impacts on global variability, biogeochemistry, ecosystems as well as society have not been adequately understood and represent significant knowledge gaps. Left brace 6.6. By 2300, an AMOC collapse is as likely as not for high emission pathway and very unlikely for lower ones, highlighting that an AMOC collapse can be avoided in the long term by CO2 mitigation. Medium confidence. Nevertheless, the human impact of these physical changes have not been sufficiently quantified and there are considerable knowledge gaps in adaptation responses to a substantial AMOC weakening. Left brace 6. The ratio between risk reduction investment and reduction of damages of extreme events varies. Investing in preparation and prevention against the impacts from extreme events is very likely less than the cost of impacts and recovery. Medium confidence. Coupling insurance mechanisms with risk reduction measures can enhance the cost-effectiveness of adapting to climate change. Medium confidence. Left brace 6. Climate change adaptation and disaster risk reduction require capacity building and an integrated approach to ensure trade-offs between short and long-term gains in dealing with the uncertainty of increasing extreme events, abrupt changes, and cascading impacts at different geographic scales. High confidence. Left brace 6. Limiting the risk from the impact of extreme events and abrupt changes leads to successful adaptation to climate change with the presence of well-coordinated climate-affected sectors and disaster management relevant agencies. High confidence. Transformative governance inclusive of successful integration of disaster risk management and climate change adaptation. Empowerment of vulnerable. Subject toolbar. Page 38. TS Technique Marker. Appearance. Search. Bookmarked. Final draft. Groups. And accountability of governmental decisions promotes climate resilient development pathways. High confidence. Left brace 6.9. Right brace. TS. Groups. And accountability. Final draft technical summary. IPCC SR Ocean and Cryosphere.
There you go. Let's hear it for transformative governance.
Camera. Take 0 people. Camera chooser. Back. Camera choose 0 people.
Congratulations, you've survived another one.
One face near top edge.
Yeah, I heard.
Centered.
I'm not turning you off yet. I'm just going to say for a moment.
Near top edge.
Well, I'm going to go right to the Safari, actually.
App switch. Safari. 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 Special report on the ocean and cryosphere in a changing climate.
There it is.
Heading level 1.
Please make use of their site. You think this was long. If you've seen any of the earlier videos, you'll know this is actually one of the shorter ones. And if you've seen any of the reports, and if you've been paying attention to how much I'm skipping, you realize that you're only skimming the surface of the Intergovernmental Panel's reports and their incredibly credible and detailed coverage of these things. So please access this. And
a talking game. 4-0.
This is us.
A talking game at
once again, all these things are linked in the comments. Feel free to contact me through this email address or go to the YouTube page and look up the other reports. And
Skip to content.
Last but not least,
image. Calgary. Image. Understanding the IPCC.
there's
Heading
this
level 1.
meetup group,
Link.
which is intended for
Main.
conversation,
Landmark.
questions, and clarification.
Actions
Look at that.
available.
Shh, I'm alliterating. And last but not least, in case it's not obvious, yeah, it's Beethoven. It's his birthday this week. 250 years ago he was born. And while you may or may not be a big fan of choral symphonic works that make some people's hair stand on end, it's pretty darn dramatic. And happy birthday, Beethoven. And let's hope that we're all around for another 250 years by acting on this research. Thanks.
Screen recording in progress.